In this lesson, we're going to model data using logarithmic functions. The equation of the logarithmic regression function can be written as y equals a constant plus the multiplier times ln x, and that's our natural log. So when you're doing regression functions, it's also always going to be the natural log. You're never going to have just a log base 10. So when you're going in there, you can see that your logarithmic function will be another menu option. So when you go into your calculator here and you go under Stat, Calc, you can see there's quadratic, linear, quadratic, cubic, quartic, which we don't use, linear, and then ln. So ln is the one we're using. In my calculator, it shows up as 9. It might show up as 0 in yours. So make sure you're looking carefully to see which value. In our notes, it says 0, but in my calculator, 0 is the exponential regression. So ln reg, don't confuse that with lin reg, which is your linear regression. ln reg is your logarithmic regression. Okay, so this first example we're going to look at, we can see how this works. And just to go back up here, sorry, when you get your menu, after you type in ln reg, you're going to get your equation. So that's your regression equation. It gives you a plus b ln x, and it's always going to give it in that format where there's a and b right there. You don't have to worry about the r's. All right, example 1. The flash on most digital cameras requires a charged capacitor in order to operate. The percent charge Q remaining on a capacitor was recorded at different times t after the flash had gone off. The T5 flash duration represents the time until a capacitor only has 50% of its initial charge. The T5 flash duration also represents the length of time that the flash is effective to ensure that the object is being photographed is properly lit. So we're going to construct a scatter plot, determine the logarithmic model for the data, so that's our regression equation, and then we're going to use that model to determine that T5 flash duration, that 50% point to the nearest hundredth of a second. So first step, let's put all that data into our graphing calculator. So we're going to go into Stat 1, clear whatever you have in there out, and put all your data in. Now that you have all your data in here, we can go to Stat, Calc, figure out what our equation is. If I go down to the logarithmic regression, there it is, hit enter and enter again. And I've got a as 0.46 if I'm rounding, and b is negative 0.099, so that would be 0.10. So if we look down at our notes, we could put that in, and you can see I did my rounding, and because I have a negative b value, I'm going to just change that to a negative. Now let's draw the scatter plot for that. So make sure your plots are turned on. So mine are on, so I can go zoom, make sure I've got something in there, clear that out. So now zoom 9 to see my scatter plot. And now I'm going to paste in that equation by using vars 5 and put in that regression equation. Hit trace and you'll have a nice curve for your function. Now in order to graph this, let's zoom out. And then you can see that function a little bit better. Okay, so you can see there's that logarithmic function. It's going through the x-axis, but it's not passing the y-axis. Okay. Now, we don't really care about quadrant 4 because we're not going to have any negative charge. Charge is in percentage, so we're not going to have a negative percentage. So if we draw this graph, we can draw this like this up until where it hits my graph, right? And I know this is going to go potentially up forever. So if I'm going to label my axes, this is my time t measured in seconds. This is my percent charge q measured in percent. And we always like to have at least one point on our graph. So if I want to find that x-intercept, I can go to 0 and go left bound, right bound, and that point's at 99.86. So that makes sense that that's 100%, right? 99.86. We can write that in if you want, 99.9% for the curve. So this point here is at 99.9. All right, the last piece of information we're trying to figure out for this example, it says use your logarithmic model to determine the T5 flash duration to the nearest hundredth of a second. So that means that's the 50%. So T.5 means a percentage of 50%. So we're setting x equal to 50%. So we're going to use second trace value, put in x is equal to 50, and we should get a y. Let's see if we do that. So second trace value, put x in as 50, enter, and we get 0.069. So what does that mean? That means that y would give us 0.0 if we're rounding 7 seconds, because that's what they wanted us to. So it'll be 0.07 seconds. All right, that's it for this example. What I'd like you to do is I'd like you to go over the next example. We're looking at caffeine and how caffeine metabolizes in your body. And I think you have enough to go through this whole example on your own. You can come back and check with my answer afterwards, but that's it for today's lesson. Just remember when you're doing this, your caffeine level is going to go into L1, and then you're going to continue this next column here. This is L1 continued. And then, so it's a really, really long list, and you've got L2 and L2 continued. Because what you're doing here, it says caffeine is found in coffee, tea, and soft drinks. Many people find that caffeine makes it difficult for them to sleep. The following data was collected in a study to determine how quickly the human body metabolizes caffeine. Each person started with 200 milligrams of caffeine in his or her bloodstream, and the caffeine level was measured at various times. So once you're done that, come back and check with my answer, and you'll see the regression equation here. You've got your natural logarithmic equation. For B, we're determining the half-life to the nearest tenth. So when something metabolizes 50% of the caffeine, we'll see half-life with chemicals. We'll see well, caffeine is a chemical, but if you're looking at the periodic table, half-life means that half of it is gone. So how long it takes for it to be half from its original state. And you'll see your graph. Make sure when you're doing your graph, you label at least 1 or 2 points along the graph. The points I chose to put on there were the ones that I answered in B and C, and you're using your second trace functions. So go ahead and do that independently and come back and check with my answers. That's it for today's lesson, and that's it for this unit. Thanks for joining me. Bye-bye.